Today I wanted to talk about how much memory a Linux process is using. So this seems like a simple question, right? Actually, it's not. It's actually a very complicated question. So let's get to that. So I have a big IP here. Customer running big IP virtual edition on the OpenStack environment, and the big IP running out of memory, and the out of memory killer uh, uh, kicked in and started to kill a process. So while investigating this problem, I noticed something here. Did you know? I noticed something here which is strange. There are like about 10 TMSH session here. About 10 of them. For example, here, this is one TMSH session, and this is the RSS, rest in the memory size, and this is the number of 4K page size memory. So there are like 10 of them with rest in the memory. And you also notice that the big IP running out of swap memory. So big IP has 1 gigabyte swap memory. So how many rest in the memory this TMSH session using? Let's calculate. So it's number of 4K page size. So it's roughly like about 77 megabytes memory. 77 megabytes memory, right? And there are 10 of them. So it's about 700 megabytes rest in the memory being used. And so the problem here is the big IP user would log in the big IP through bash and then start a TMSH session. They run a few commands. Then after that, the user will just go away, forgot to log out, and so they leave like 10 of TMS session running there idle without actually doing nothing. But so the customer asked it, since the TM session is idle and the memory should not be used, so why the big IP running out of memory? So that's a fair enough question, and so that make me to think how much memory a Linux process is actually using. Does the rest in the memory really mean that much memory is actively in use? And from this example, it is apparently not, because the TMS session is idle and user are not using the memory, but this rest in the memory is still being held and not available for use. So by the way, for this particular problem, we big IP we have a solution which is you can configure TMSH session idle timeout, and so even if the customer forgot to log out after the timeout, you can configure the TMSH will exit itself. So here is the Ask F5 solution. You can configure idle timeout for the TMSH session, and yeah. So I also file an internal request for enhancement. Maybe by default we should enable idle timeout and just let TMSH log out itself without configuring the idle timeout. Yeah. So this is the Ask F5 solution. Okay, so but I want to talk about the Linux memory usage. So which I did some research and I found this Brendan Gregg's blog. So he's very good at performance analysis, and this is one of his blog talking about a memory Linux memory working set size. And so here he has a method to check how a memory is being used, how much memory is actually being used by a process. And so he has this Perl script to do that. And I recommend you read through these blogs, and it's very informational. And here it explains you what's resident memory size, and the PSS is proportional set size, accounting for shared pages. Yeah, so it's good to read it. And this is another good article from Linux Weekly News. It's from it's also like so in the kernel there's a new feature called idle page tracking, and yeah, so it's good to read. So based on that, let's go take a look at BigIP here. So I have a BigIP here. I have two SSH sessions open here. So in one of this SSH session, let me start a TMSH session. Okay. So I just leave it there, doing nothing. Just make it like an idle TMSH session. From another SSH window, let's see. So let's see. So we have this TM shell ID, process ID open by another window, right? So let's look at this TMSH session memory usage and see how many memories it's being used. And let's give it 5 seconds. Or the out of memory kernel output. So this is the actual memory, including the shared memory portion. The TMSH session has, and so this is this is the actual memory the TMSH session is referencing. So as you can see, this should be the correct memory usage, like how many memory actually referenced here, because as you can see, I just leave the TMSH idle here, so it's actually not using any memory, and that's why here it's 0 memory referenced. So I think that's more correct way to check how a process, Linux process, is using memory. And so let's run some command here and see this LTM virtual, right? So right now I'm actually using some memory, right? I'm running some command in this TMSG session, and I should reference some memory. And then let's run this command again and see if the reference the memory. Actually, I should run this longer, and yeah, let me start this maybe 30 seconds first, and then let's run some command here. So it's not an idle session, we're actually running some stuff. Okay, I think that's good enough. And let's see how much reference the memory is used. Okay, see right now it's like 4.6 megabytes memory. So that's in the past 30 seconds. That's how much actual memory being used by the TMSG session. And but when the Linux kernel auto memory killer, when it's doing memory swiping the memory, those memories are not considered active and considered quote used, and so yeah, that's unfortunately situation. So this is one way to measure how a process, how much memory a Linux process are using. And in this blog, so that's and that's what we are doing here. So there is a second method. This is this idle page flag. So this is a more accurate way to check how much memory a Linux process is using. But this is a new kernel feature and added. So it's still not available for Big IP kernel, Linux kernel. So and there's some example, but yeah. And anyway, so just some again Linux memory probably and how it's affected the real world. And yes, thank you. Oh, if you like my videos, please subscribe, and so that I would like make more videos just out of my daily work and learning experience and share my knowledge. Yeah, thank you.